back 8th graders. We're going to get into our very last portion of Chapter 7. And this is 7.6. In Example 1, this is what our objective is. We want to tell whether each expression is completely factored, and if it isn't, then finish factoring it. Okay? So let's look at letter A. I'm going to do all of these just because I think you need me to do all of them. I want to help you with that. There are things you need to look for to tell whether something is completely factored. Okay? Let's look at letter A. It looks like they pulled out a GCF here. Okay? We've done that. We know how to factor out a GCF. Now, what we want to do is we want to look at the quantity that's left behind. One thing that I always, that's a flag for me, is I look for an exponent of 2. If I see an exponent of 2 on my variable, then I'm going to look at that a little bit more deeply and see if I can factor it. Okay? If it's an exponent of 1, then I don't need to worry about factoring it necessarily. It might need a GCF pulled out of it, but if it has a 2 on it, it might be a trinomial or a binomial that could be and is possibly factorable. So I look at that and I go, x squared plus 4. Could that be the difference of 2 squares? X squared is a square, 4 is a square. They're perfect squares. And is it a difference of 2 squares? Now, hopefully, you're going, no, it's not a difference of 2 squares. It's a sum of 2 squares. And you would be right. And so, this one is completely factored. I cannot factor a sum of 2 squares. And so I'm finished. They pulled out a GCF, and that is all that could be done there. And there's no more work to be done. Okay? Let's see. Let's look at letter B. Well, it looks like they factored a trinomial and got these 2 binomials. That's what it looks like. Okay? Now, I don't see any squared exponents, so I don't think it's a perfect square trinomial or a trinomial. I don't see any trinomials there. I don't see the difference of 2 squares. What I am going to look for is I'm going to check my quantities and make sure that all GCFs have been pulled. Okay? So let's look at this first quantity. I have a 2 and I have a 6. Is there a number that's the GCF, greatest common factor of 2 and 6? Well, yes, there is. There is a GCF there. So that's what we're looking for is in these quantities, is there a GCF? And there is one. We need to pull that out. So what is the GCF? And hopefully you're thinking in your head very loudly, I think it's 2. And what's left behind if I undistribute a 2 from this quantity? You're right if you said x plus 3. Then you just drop that x plus 5 down because it has a GCF of 1. That's what you're looking for in your quantity, okay? If it's got a squared variable, then look to see if you can factor it. If it doesn't have a squared variable, then look to see if the quantity has a GCF that can be pulled. And as long as the GCF is 1, you're done. And now we're done because we pulled all the GCFs out and we just fully factored it. And that's as good as I can get it. Okay, all the other quantities, x plus 5 and the x plus 3, they both only have a GCF of 1. So we're done. All right, let's look at letter C. 5x squared times the quantity x minus 1. This clearly appears to be the GCF that was pulled out. Okay, the 5x squared. I can't do anything with that. So let's focus in on the quantity. There's no variable that's squared. I don't see a GCF, so it is completely factored. There's nothing else I can do here. So I'm going to leave it alone. Okay, and then let's look at letter D. Letter D, no GCF that I can see, just 2 quantities. So we definitely want to pull and assess to see if we need to pull a GCF out since we don't see one out in front. So let's take a look. Now this quantity, what's common to 4x and 4? Well, I think you heard me say the word 4 twice, so let's pull out 4. That's going to leave me with x plus 1, and then I'm going to drop down that other x plus 1. Now I am fully factored, and this is it, okay? And so I pulled out a GCF. There were no squared variables, so I didn't need to worry about factoring a difference of 2 squares or factoring a trinomial. I just needed to look for a GCF in the 2 binomials there. Okay, so that's it for example 1. It's pretty tricky, so we'll practice this tomorrow. So if you're not quite sure what's going on, I'll show it to you again with some other examples and let you try some on your own, okay? Thanks for listening.